So I'll start. So we're going to start experiment 10 here, titration of an unknown. We're going to do part 1 and part 2 today. And so we're going to do unknown base. The base is actually sodium hydroxide with an acid standard. A standard acid means its concentration or its composition is known fairly precisely. And so the standard acid we're going to use is this. It's going to be HCl, and the composition is 0.1032 molar. And so we have 4 sig figs, and in a standard you want that known to as many sig figs as possible. And so standard, this has been verified, checked. And so we just know the concentration. However, this sodium hydroxide solution that we're using, which is strong base, we don't know exactly. They just made it approximately 0.1 molar, but it hasn't been standardized. That is, we don't know what its concentration is accurately. We just know what it is approximately. It's approximately the same. But what we're going to do in part 1 is we're going to determine this concentration to 4 sig figs, the sodium hydroxide. And so this is the first part of this. Here's the reaction. We're doing sodium hydroxide and hydrochloric acid. That's just going to form sodium chloride and water, salt and water. So it's a double replacement or a Bronsted acid-base reaction. Okay, when we go to the procedure, we go to the stockroom, we get a burette clamp. Okay. This is a burette clamp. A burette clamp holds two burettes. You know, you'd have one on the left side and one on the right side. It's a pinch clamp like this. And then there's a screw nut that we can use to lock it onto a ring stand. And so the burette clamp is going to go onto our ring stand like this. And then we'll just tighten it here. Okay. The burettes and burette funnels. The burette funnels are just these little funnels. I don't know have any. Don't have any, so we might have to just pour it with a small beaker. If you have a funnel, sometimes it's helpful to use a funnel. But the burettes are $200 a piece, so you got to be very careful with these, and they're pretty fragile. They're pretty easy to break. And so you get one with a blue stopcock or valve, and then one with a red. I'll call this red stopcock or valve. The blue one we're going to use for the base. The red one we're going to use for the acid. So the blue one we'll put in our sodium hydroxide, red one we'll put in our HCl. Now we got to see if these are clean. And so when we have a stopcock valve like this, when the valve is parallel, it's open. When it's perpendicular, it's closed. So any perpendicular position is going to be closed. And so this is closed here. One way we can tell how clean our burette is by just running. I'm going to close it. And I'm going to squirt some water in here with the wash bottle. I'm going to squirt it down the sides. And as I squirt it down the sides, I'm rotating it. And what I want to look for is I want to look for if there are any beads. You know, a clean burette should wet the surface. There should be no beads. There are some beads at the top here, but it's not that significant. So this burette looks pretty clean in the sense that there are no oily contaminants in there. And so what I'm going to do is I'm not going to wash it with soap. If I'm getting a lot of beading on the surface, inside surface of this, I'm going to wash it with soap. But washing it with soap means these burettes aren't so easy to wash. And so one thing that helps in lab is if you're not close to a sink is to grab a big beaker. And we'll label this beaker waste. And so we want to have a waste beaker at our station so we don't have to walk back and forth between the waste bottle and the equipment. Okay, so here, again, remember, if you're uncertain what's in here, dump it and then rinse it with DI and then fill it with DI. Okay, so I'm gonna just discard this into the waste here. Let's show that here. So sodium carbonate again. And so what I want to do is, well, that's kind of slow, so out the tip, but I want to rinse the tip and the inside walls of this. burette. So maybe about 2 or 3 times. So again, I'm going to wash some water in here, about 10 milliliters of water. Not too much. Just rinse off the inside surface like this with a rinse bottle. And so in this case, I got about 15 milliliters. And then I'm going to pour out some, and you can see it's draining out the tip there. And then I'm going to close this, and then I'm going to invert it and then just rotate it and rinse out the inside walls there. Okay, now this burette is going to be wet with DI water. And so the burette's wet with DI water, and this is the acid burette. And remember, the acid is a standard acid solution. You know, it's 0.1032 molar. So if I pour this acid solution into a wet burette, what's going to happen is it's no longer going to be 1032 molar. I'm going to get solution dilution. I don't want any solution dilution happening here. And so let me drain off all the water. The problem is I'm not going to be able to dry this. You know, it's just too difficult to dry. So as an alternative to drying, this is what we're going to do. And I don't have a, actually I don't have a funnel right now. So I'm going to just pour this into a small beaker, and I'm going to use this HCl, you know, from my standard as just rinse. And so I'm going to sacrifice some of my HCl standard to rinse off the water from my burette. And so I'm going to pour the HCl in here, trying to rinse off the water here. And so I just poured in about 5 milliliters in here, and then I'm going to drain this here so I can rinse off the tip as I drain this. Okay, let me close this, and I'm going to get another about 5 milliliters worth of HCl standard. I'm going to rotate it on the inside here and rinse it off this. So that's another 5, and then let's rinse out the tip. And so what I'm doing is I'm just washing the water out of this using the HCl solution. And let's do that one more time. So close this, and then pour another portion of the HCl in here. That. And then I can rinse off, I can hold it horizontally and just rinse off the inside surfaces just to make sure I got everything. And then just dump it. Okay. And so by the 3rd time, now this is still wet, but it should be wet with HCl. And I've rinsed it off so many times that it should be wet with HCl standard, not diluted HCl standard. And so that just should be HCl standard. All right, so I dump out, that was my final rinse. And now I'm ready. So there are 2 ways you can fill a burette. Okay, one way is, obviously we gotta make sure this is closed, so it's perpendicular. One way is to use a beaker, small beaker. Another way is to use a funnel. Since I didn't grab any funnels, the funnels sometimes are a hassle to use because there's a little bit of suction there. And, sometimes it doesn't flow so nicely. And so what I'm gonna do is I'm just gonna fill it with a small beaker. Now this beaker is only for the HCl standard. So I'm not going to use this beaker for anything else. All right, when you look at the markings on a burette, the markings at the top is going to be 0 milliliters. And so what we're going to do is we're going to fill this above the 0 mark. I'll show you why. I'm going to pour a little bit more HCl. I need some more into my transfer beaker. And then fill this above the 0 mark here. The reason I'm going to fill it above the 0 mark is because I need to fill the tip of the burette. Right now, the tip of the burette has a huge air pocket here. You can see where the liquid is. There's a little bit of HCl trapped in the tip, but then there's this big air pocket here. And so I got to get rid of that big air pocket. And so the way to get rid of that big air pocket is to use the waste beaker. But the air pocket is difficult to get rid of, usually, if you hold this vertically. And so if you hold this near horizontal, then it's easy to get rid of the air pocket. And that's because it's like this. The air pocket's like a balloon. So to push the balloon deeper is harder, but to push the balloon to the side is easier in a swimming pool, let's say. So let's move that to the side here. And so I'm going to get rid of the air pocket by tilting the burette from vertical to not quite horizontal, but you know, close to it. And then keep an eye on the air pocket there. Here. And so, okay, there's still a little bubble left in there. There's still a little bit of a bubble left in there. So I'm tapping this to see, okay, now it looks like all the bubbles are gone. And I got rid of all the air pocket that was stuck in there. And so now the tip is just filled with liquid and there's no air pocket. You look very carefully at the very top here and you look inside the hole there and you look for little air bubbles. There are no air bubbles there. And so that's good. Except take a look at my level now. My level's way below the 0 mark. And so I need to refill the burette because I wasted so much HCl trying to get rid of that air pocket. And so I'm going to refill the burette with HCl, but this time I'm not going to go above the 0. I'm going to stay below the 0 mark. Okay, so I just make sure I stay below. Do I want to start right on 0? No, because you know it takes too much time. It's a waste of time to get there with a dropper and then carefully drop it until you hit the 0. It's better if we just start below 0 and then just measure that precisely. And so that's what we're going to do here. I'm going to take a measurement and try to measure that precisely. Now, I'm going to get a little meniscus reader here. I'm going to make homemade. Let's see if there's one already made. Yeah, there's some that were already made by some other people. And so this is our meniscus reader here. It's just a piece of paper and somebody just printed it with a black line there. And what we can do is we can hold the burette and hold the meniscus reader underneath the meniscus to darken the line here. So let me see if I can show that to you here. And so take a look at the meniscus there. And then actually you probably can see it pretty good. We'll just bring this up until you can really make the meniscus stand out there. And I'll take a photo of that. We can take that measurement. So I didn't start it right on the 0 because it's a waste of time, like I said, to start right on the 0. So this is where I started here. Now each line is 0.1 milliliters. So it's 0.1, 0.2. This one I'm 0.1, 0.2, 0.3, 0.4. I'm between 0.4 and 0.3 and 0.4. And so it's between 0.3 and 0.4. So what would you record that as? It's kind of hard to see the 0.3 line. So if you're having trouble seeing that, let me take another photo and see if you can see that a bit easier. Maybe this is a little bit easier to see. Somebody read that?
What's it between? The whole numbers?
0.4. So Maniza, you say, okay. Let me do one more shot. 0.3 and 0.4. One more photo. Maybe this one might be easier to see. Actually, that one's going to be harder. Okay, so I rotated a little bit, so make it a little bit easier to see. Okay, you're getting 0.34. Actually, yeah. It's hard to see. Maybe I would think it's maybe not quite halfway, but actually a little less, quite a lot less. Me, I would mark this as a 0.32 or a 0.33. You know, it's probably hard to see because you aren't getting the same resolution I'm getting from looking at it right off my phone. But it's looking like a 0.3, yeah, 0.32 to me. And so that's our initial volume is a 0.32. And there's no air in the pocket here, and we're starting off with initial volume of 0.32. So I'm going to put that over here. Put that on the, now with this, it's a pinch clamp here. The burette, it's a pinch clamp, so I'll just undo it here. Now when you pinch this in here, a lot of times what happens is it looks straight, doesn't it?
Yeah.
But when you look at it from this angle, it's tilted here. You see, and we don't want it tilted. And so we got to make sure it's vertical from all sides here. And so sometimes somebody's looking at it straight like this, but it's actually tilted back at a pretty severe angle. And so we could raise and lower this. Now, we're going to clean the second burette the same way. First, we check, if it's excessively dirty, then we'll have to use some soap. If we have to use some soap, then that's going to involve lots of rinsing. And so when I look at the water here, the water is wetting the surface pretty well. There are not too many beads that are forming. This burette's a little bit dirtier. This burette has some beads of water here. See, and those beads of water are trouble because those beads of water don't sink down to the liquid surface. Liquid surface down here. Those beads of water get trapped there, and those beads of water are going to lead to an error in the volume. So this burette is a bit dirtier than the other burette, and since there are beads of water forming in this burette, it's probably a good idea to clean it with just a little bit of soap. Now, there's special brushes that we could use to clean this. Unfortunately, we don't have them. And so I'm just going to put a little bit of soap in here, like a drop of soap. And then what I'm going to use is I'm going to use DI water here. Actually, let me get it over here. Actually, with the soap, we're supposed to just use tap water because tap water is a lot less expensive. And so I'll just use tap.
For experiment 10, it says molarity of the standard acid. What do we put there? Okay. Do we have to put those numbers too?
The molarity is the numbers.
Okay.
0.1032 molar. You have to put that there.
Again, can you read the numbers again?
The whole standardization process is knowing the composition to a lot of sig figs. That's the whole thing. And so you need as many sig figs, at least 4 sig figs, you know. Some standards have more than that. Okay, so I'm using a tiny bit of soap here to do it. So you can see the suds here. So let me go over the sink here and try to clean this off as best we can. Just soapy water. That's because I was getting too many beads in there of water that weren't sinking down. And so I'm just going to spray out the soapy water out the tip. But that's going too slow, so I'm going to invert it and then just dump it into the sink like this. And then I have to rinse it a lot. To get rid of the soap. So I'll, again, rinse the tip out. I'm not going to drain the whole thing. It'll take too much time. And then rotate and then dump it out the top. And let's fill it up again with some warm water. Water's not very warm, so just some warm water. Again, rinse the tip. I got some soap on the outside. Rinse that off. Okay, and then dump out the top. Here. Rinse off. I got some soap on the outside and rinse that off. Okay, give it one more big rinse with lots of warm tap water. Out the tip, and then dump it out the top here. Okay, let me dry. Actually, I need to. That was tap water. Then I need to give it a rinse with DI water. I'll use some DI water here. Rinse out the tip with DI water. I put in a lot of DI water here. Okay, and then rotate it. Rinse out the top there. Okay, let me rinse off the outside. I have soapy hands, soapy fingers. I've got soap on the outside here. Okay, let me give it another rinse with DI water. Rinse out the tip, and then dump it out the top like that. Okay, let me dry off the outside of this. I can't dry off the inside because it's quite difficult. Stuff inside there. Unfortunately, there's still a lot of beads of water. You know, beads are little droplets of water. Let's take a look here. I'm going to try to rinse those beads down. I'm going to need to refill my bottle here, so let me refill that. Okay. So I do that, and then I inspect this. The other burette didn't have so many droplets stuck on the inside wall. That's going to lead to an error here. This burette's still dirty. The next level is I need to get a brush and brush the inside walls of this. Otherwise, you know, these droplets that adhere to the inside wall are going to lead to error. But I don't have it. Unfortunately, I don't have a test tube brush. Here, I gave it to you too. Okay. Since I don't have a test tube brush and I don't have a lot of time, I'm not going to try to get it any cleaner than this. Okay, so I had the, this is the transfer beaker for the HCl, so we got to make sure we label everything. Otherwise, it's easy to get things mixed up. So this is HCl. And then I need another small beaker, clean beaker for the sodium hydroxide. So I'll use this one for the NaOH. I'll label that NaOH with a Sharpie. And I'm going to pour my NaOH. Since I don't have a funnel, if I had a funnel, then I'd use the funnel and I'd just pour directly from here. But, you know, I find it easier to pour from a beaker than to pour from a round Florence flask into a funnel, into a burette. Those funnels don't work so great. And so the next step here is to wash this. I'm washing off the water, the DI water. And so what I want to do is I want to rinse off all the DI water. So I'm going to tilt this. I'm using sodium hydroxide solution to rinse off the DI water. And then I'm going to dump this into my waste container, which I have here. This is my waste beaker. And so let's just dump it into the waste beaker. Yeah. And so, well, it takes time. So, plus I want to rinse off the top part. So I'm going to invert this. Oops. I was trying to raise it up so you guys could see it, but it's spilling it on the computer. I'm going to invert this and then just rinse it off the top. Okay, let's get some more sodium hydroxide here. And rinse with another portion of sodium hydroxide. Again, about 5 milliliters here. Okay, rinse out the tip. And then invert this. And then rinse out the mouth or the top of the balls. And so one more portion of sodium hydroxide should be plenty to wash off the water. And so I'm rotating this, so I'm rinsing it down the sides. Again, I'm going to drain some out the tip and then out the top. Okay. All right. So that should be enough to wash off all the water, and then I'm going to fill this. I'm going to fill this above the 0 mark. Here. Get some more sodium hydroxide. Okay, I'm going to fill it above the 0 mark to get rid of the air pocket that's in here. And so let me go ahead and try to get rid of that air pocket down here. Some paper towel to dry out the spill I had earlier. So I hold it at an angle and then tap it. I have an air pocket in there. It's hard to see. Let me see if I can show it to you. There's a small air pocket in there. Watch when I open this. You can see that. Maybe it's out of there now. Yeah. Doesn't look like there's any air pockets in there now. Okay, so we're good. I'm going to close that. But I drained about this much sodium hydroxide to get rid of that air pocket. And so I need to refill this. But this time I'm going to refill it below the 0 mark here. And then I need my meniscus reader here. And then let's record the initial amount of base. And so what I want to do is I want to hold this, you know, two things to make sure that you do. And one, you don't want parallax, you know. What you want to do is you don't want to hold it high like this, and you don't want to hold it low. You want to hold it perpendicular with your eye level, the meniscus. And so we've got to make sure it's perpendicular to the eye level, and that way we can get an accurate reading. So I'm just going to let this hang by gravity here. Take a picture of this here, meniscus reader. I would normally have the meniscus reader a little bit higher than this, but I want you to see the 0.5 line here. And so what do you read that as? It's just below the 0.2 line. So me, I would read that as like a 0.21 maybe, or 0.22. And so when I look at this, I would go with a 0.22 myself, you know, 0.22. And so what we'll do is we'll put that on the base side here. And it depends on if you're left-handed or right-handed. Since I'm right-handed, I like to have the stopcock face to the right. And so I'll just twist this to face to the right here. Make sure they're vertical, both this way and this way. And then I need to record that data. And so let me put that in the notebook here. And so we'll put in the HCl and the sodium hydroxide, you know, HCl and sodium hydroxide. And then what we're going to do is we're going to write V initial. So the V initial for the sodium hydroxide we just did, that was a 0.22 milliliters. And the V initial for the HCl, I didn't write down, but I think you guys had it earlier, 0.32, I think was what we decided. 0.32 milliliters. And those are initial. And then we only need one more data, and that is the V final. Now, V final, this is going to be at the absolute end. And so we're going to make, probably we're going to make a bunch of stops, but we aren't going to keep recording each stop. We're going to, V final will be the total volume of base and the total volume of acid that we've added. Now, that's going to fluctuate because of the way we do this. So the way we're going to do this is we're going to use an Erlenmeyer flask. And then it says, the instructions say to do what? Let's see. 20 milliliters is a standard acid. And so we're going to run about 20 milliliters. But I'm not, you know, I'm just going to get about 20 milliliters. Because at the very end of this, then I'll record everything very precisely. So I'm going to go around 20 and stop. So 20 is about here, and then stop. Okay, so here I have my Erlenmeyer flask. I'm going to put the mouth there, and then just go ahead and run about 20 milliliters. So I'm going to watch this here, and when that gets to about 20, which is there, I'm going to stop it. And so I hit about 20 milliliters, I stopped it. Now there could be a drop here on the tip. If there's a drop here on the tip, I touch the tip of the burette to the inside of the flask. so I get all of it. I want to make sure all of it gets in here and there's not a drop hanging there. Okay, then I need to add a drop or two of phenolphthalein.
Professor,
Yeah.
it's break time.
Okay, since it's break time, I'll stop here and then we'll continue after the break. So we'll meet again after the break. Okay, we're going to start again. So right now in the Erlenmeyer, I have 20 milliliters roughly of the standard acid. I can measure precisely how much I have in there, but I don't want to do that until the very end. And then I'm going to measure it. Next, I'm going to add some indicator. The indicator is going to tell me when to stop the reaction. And so the indicator is phenolphthalein. In acid, phenolphthalein is colorless. In base, phenolphthalein is pink. So I'm just going to get a slight pink color. That is, I'm going to have just a slight excess of base in here when you neutralize. When we neutralize the acid, it should go to neutral. And then if I add a little bit of excess base, then it should go pink. And so it's just a tiny, tiny bit of excess base that we're going to add in there. So I'm going to add a drop or two. Let's put in 2 drops of phenolphthalein in here. Okay, the reason we use Erlenmeyer's is, oh, this is leaking a little bit here. The reason we use Erlenmeyer's, I'm going to touch it. There's a little drop that was forming on the tip. I didn't want to lose that. Anyway, I'm going to put it in here because we already measured it. Is you can swirl these easily without splattering out the top. So these you can mix rapidly. And so that's the nice thing about the Erlenmeyer design of the flask. And so what I'm going to do is I'm going to lower the tip a little bit so there's no splattering. I don't want any splattering coming outside, then I'm losing some reactant. And then I'm going to use my right hand or my left hand. I'm going to use my right hand. So I'm going to tilt or rotate this so I can use my right hand on the valve here. Now, oftentimes what we do is we do a quick titration as a throwaway, you know, just to get it. But all our titrations we can do quickly as kind of a throwaway because the way we do Chem 4 is a lot different than the way we do Chem 1A. So I'm looking for the pink color. And right now, I don't know if you can see it, but there's a slight pink color here. If I put that under there, well, I guess it's too washed out. Oh, this is kind of dirty. And so I'm looking for a slight pink color here. I do that. Maybe you can't see it. Let's do it some more. And so this time I'm just going to raise this to prevent splattering from happening. And so I'm just going to keep adding it until I see a pink color come. Okay, now I see a pink color come here. Okay, if there's a drop suspended there, tap the inside of the burette tip. Tap the burette tip to the inside of the flask. Now, do you see the pink color there? That's what we're looking for. That pink color is going to tell me to stop. The situation is I need it to go from colorless to pink. And that's when I know when to stop. Because here, well, one thing is this wasn't mixed thoroughly. So if I mix this now, the pink color disappears. So I need it to go from colorless to pink with mixing, and then the color persists. And I'd like to do that within a drop or less. And so let's go ahead and add some more until I get a more persistent pink color. Okay, here I'm getting a much more persistent pink color. And so you probably can see it, the pink color there. But that pink color is likely to disappear when I swirl this because it just wasn't properly mixed. And so let me swirl it. I swirl it, and I swirl it. And unfortunately, it didn't go back to colorless because I wanted to get it within a drop, but I don't know how many drops I added when it started to turn pink. I overshot this. I could overshoot it by a lot. Let me just dump in a whole bunch of excess. So I'm not looking for the pink color. I'm looking for the color change because I just added a whole bunch of extra and it's still light pink, the color is. And so I can add even more extra and I can't tell the difference in color. So I just added a whole bunch of extra drops and I really can't tell the difference in color. And so the critical thing here is that I need to get it from colorless to colored, and the color has to stay. So it's going to be colorless, and then a half a drop later, it should be colored. And so in Chem 1A, I just ruined this one in Chem 1A, but in Chem 4, I didn't, because in Chem 4, we have a double burette system. If I overshoot this in Chem 1A, I got to start over again. In Chem 4, I can do what's called a back titration. And so I added too much base. And so what I'm going to do is I'm going to now fix that by adding acid. And so I added too much base, I overshot it. So what I'm gonna do is I'm gonna get this back to colorless, you know, by adding acid. And so let me wait until this goes colorless, and then I'm gonna stop. See, I added way too much because look how much acid I'm adding, and it still hasn't gone colorless. Let's see, let's mix it. Okay, there. So now it's gone colorless. Maybe it was too much. I should have mixed it there. Okay, so I need to swirl it. I need to make sure I wash the droplets. This Erlenmeyer isn't the cleanest, and then there was splattering on the inside surface, so I'm gonna just wash all the little drops that got splattered on the inside walls down. Okay, now I'm gonna go slow. I wanna be careful. And so what I'd like to do is I'd like to get it within a drop. So I'm gonna slow down the rate. Now it's going drop, drop. I just barely changed this. So drop, drop, and then I'm waiting to see it turn pink again. Drop, drop, drop. It hasn't started turning pink yet. And so maybe I'm still far off. So let's increase the rate, the drop rate. So now it's drop, drop. I'm going to increase a little bit more. Drop, 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 drop. And then see, let's go a little faster. I probably overshot it with the acid. Still hasn't turned pink. So let me increase the rate here again. Drop, 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 drop. Pretty soon you lose patience. It's going so slow. Maybe I'm far off. I don't want to be here forever. And so I'm going pretty rapid drop rate right now. It's not a stream. It's just dropping pretty fast. Oh, there, it's starting to turn pink here. Now it's starting to turn pink again. I'm going to swirl this and see if it stays pink. It didn't stay pink. Now I know I'm getting close. So if I'm getting close, what I'm going to do is I'm going to slow it down. I'm going to just try to add one drop at a time. And so here, I'm going to try to add one drop and then see. Actually, it didn't turn pink. I'll add another drop. No. Another drop, no. Actually, I'll just go with a slow drop rate until it turns pink again. Drop, drop, drop. It turns pink because of concentration gradients. It's not well mixed. So after swirling it, okay, now it's starting to turn pink. It's an extremely light pink color. It's hard to see probably, but there's pink in there. Maybe you can see it. But when I swirl it, oh, when I swirled it, it did turn a very light pink there. All right, and I keep swirling. It has to stay pink for 30 seconds. And so I might have overshot it. So what I'm gonna do is I'm gonna just add one drop of acid here. And so let me try to add just one drop of acid to reverse it. Okay, oops, that's 1.5 drops. There's a drop, half a drop suspended on the inside. I'm gonna tap it in here and then rinse it in by swirling the Erlenmeyer flask up the walls. Okay, that was 1.5 drops of acid and it's still pink. So let me add another drop of acid. Oops. That's 2.5 drops of acid. With 2.5 drops of acid, it reverted back to colorless. And so I'm gonna go back here to the base, and then I'm gonna add one drop of base and see. Oops, that was more than one drop, but let's see. Shoot, that was more than one drop. But that's okay. I'm going to go back to my acid and add 1 drop of acid and see. So let's hope I can get just 1 drop. There it is. Actually, that's a half a drop. I don't know if you could see it, but there's a half a drop suspended on the tip. Let me raise this up. But oh well, I'll just tap it in. So I tapped it in there, but I just tapped it in on the inside wall. I'm going to wash it in here. All right, it's still pink. And so what I'm going to do is I'm going to just add another half a drop or drop. Okay, that was a full drop that I added in there. And so with 1 full drop, it went back to colorless here. Actually, there's a 1/4 drop suspended on there. So that 1/4 drop I'm going to tap in here and then rinse that in because that 1/4 drop is measured off the burette. And so now I'm going to go back to the base. And what I'm going to do is I'm going to just try to add half a drop. To add a half a drop, I'm going to suspend that. Okay, so right now there's a half a drop suspended on the tip of the burette. I don't know if it focuses or not on there, but there's a half a drop. So what I'm going to do is I'm going to tap that half drop in by touching it on the inside wall of the flask here, there, and then it's in there, but it's on the inside wall. So what I'm going to do is I'm going to swirl the flask to make sure that it gets washed in there. Okay, it turned pink for a moment and then it reverted back to colorless. And so what I'm going to do is I'm going to do the same thing. I'm going to suspend a half a drop on the tip. And so I'll slowly open this and then just get about a half a drop on there. It takes a full drop to fall. And so there's a half drop suspended. It's not going to fall because it's not a full drop, but I'll touch it on the inside wall. There's 2 things. I could touch it on the inside wall to drop it in, or I can rinse it in with my wash bottle. I just touched it on the inside wall. I'm going to rinse it in here. Now take a look at the color here. Now it's pink. And so I got a pink within a half a drop. The pink is so faint, you can barely see it. You probably can't see it in the camera, but it's so faint, it's hard to see. Let me see it on a white background if you could see it. Now, what we want to do is we want to make sure that pink color lasts or persists for 30 seconds. And so it didn't. The pink color is now gone. And so I'm going to repeat this. I'm going to get a half a drop here. Suspended. Okay, there's a half a drop there. But this time I'm going to get a wash bottle and wash that half drop in there. And so that's the other way to get a half a drop to go, is to rinse it in there with a little bit of water. Oops. Okay, I don't know if you could see it, but there's a slight pink color. So it went from colorless to pink with a half a drop. We just got to make sure this pink color persists for 30 seconds. And so we should time it now. Let's see. So I'll start my stopwatch. It's still pink. We've got to make sure we washed all the inside walls off because we can have some splattering, and splattering could change it. But it's still pink. It's a very, very faint pink, but that's all you need is a very faint pink color, and it's fine. Okay. So it's been 30 seconds now, and the color's still there. And so we hit it within a half a drop. Okay, now what we're going to do is we're going to take a measurement of the, oops, now look at, there's another there's a drop suspended. This burette is leaking, unfortunately, because the valve is closed, and yet there's another half a drop suspended there. That's going to make this even more pink, unfortunately. So we're going to be a half a drop too much. And so what I'm going to do is I'm going to go ahead and tap that in. If I tap that in, it's going to deepen the color here. And so I'm a half a drop too much, or drop too much. And so I'm going to fix that by adding just a half a drop of the base. What I did was there's a little, there's a little nut on the back. I just tightened it. I think this was too loose. That's why it was leaking. And so I'm going to add my acid now. I'm just going to add a half a drop of acid to compensate for that. Half a drop of base that was added. And so let's go ahead and do that. Okay, so I suspended a half a drop there. And the half a drop, rather than, well, I guess I could tap it in there too. But tapping in, we got to worry about cross-contamination as well, but it's all right. Tap it in there and oops, and then rinse it in. And now it's colorless again. And so now I'm going to rotate this back over here. And then I'm going to suspend a half a drop of base here on the end here. Okay, so I have a half a drop of base suspended on there. I'm going to tap this one in here like that and then swirl it in. Let's see. Okay, there's a very, very faint pink color, but I don't think that's going to persist. I'm going to have to add another half a drop because color was too faint. And so let's add another half a drop here, like that. Okay, and then this half drop, I'm going to use, this is the proper technique, is just to rinse it in with the spray bottle. So I'll rinse it in with the spray bottle, like that. A bit of DI water got caught in there. Okay, now I got a pink color here. The pink color is very, very faint. But again, that's all we need is a very faint pink color. It doesn't have to be so bright. It just has to persist for 30 seconds. Well, that pink color did not persist for 30 seconds. It faded. So let me add another half a drop in there. And so I got a half a drop here. I'm just going to tap this one in here, touching the inside wall. Okay, so now I have the pink color. This one's a bit darker. Let's just see. That's within a half a drop. Let's see if this one persists for 30 seconds. So let me set the timer. Yeah, and we'll wait and see. Make sure it's well mixed. Okay, it's been well over 30 seconds. And the pink color is still there. Barely can see it, but it's still there. It's definitely pink. And so we're good. This one's good. I don't know if you can see it, the pink. It's just very faintly pink there. From certain angles, you probably can see it. Take whatever you need. Okay, so now we're done. We got the colorless to pink within a half a drop. And so what we're going to do is we're going to take our final measurements here. We'll take our final measurements of acid and final measurements of base. And so let's go ahead and do the acid first here. And so I'm going to lower this a little bit. So take the volume measurement. Okay, well, what I'll do, since this is not focusing very well, let me take a picture of this and then get it that way. camera, it's hard to see where the lens is on the camera. Lining up the lens. Okay, this is the acid. And so what do you read the acid as? I read it as, okay, it's almost 36.5. It's between 36.4 and 36.5. And so what would you call that? Okay, it's 36.4 something. It's between 36.4 and 36.5. So are you saying 36.44 or? Yeah, I'd say 36.5 maybe, yeah. Or even 36.6. You know, it looks like it's slightly past the halfway mark. Yeah, I'd probably say 36.6. Okay, that was the red, and so that's the acid, 36.6. Let me write that in the book here.
Isn't it 0.46?
Oh yeah, sorry, 36.46. 36.46, the final of the acid. Okay, let's take a look at the base. And so let me lower the base here. I'm going to take a picture of that as well. Here. All right, this came out a little bit blurry. Let me try that again. Let's see if that came in focus here. Yeah. All right, this one is between 38.0 and 38.1. And so for me, it could be a 38.10, you know, if it's right on the line, but it might be just a hair above the line, you know, the center of that. And so maybe a 38.09. So for me, I'm looking at a 38.09 or a 38.10. What do you guys think? 38.10? 10? All right, we're going to go with 38.10. Looks like it's right on the 0.1 line. You're right. And so that's the volume of the sodium hydroxide, 38.10 milliliters. Now, we're going to have to do a calculation here. And the calculation that we're going to do, let me just do it over here. I'll do it on the paper here first, is we want to know what the molarity of the sodium hydroxide is from this trial. And so I'm going to calculate the molarity, capital M of NaOH. And that's going to equal the volume. Okay, so it's going to be the moles of sodium hydroxide over the liters of sodium hydroxide solution. Okay, the liters of sodium hydroxide solution is, well, how much did we use? Okay, so we used, it's 38.10 minus 0.22. And so that's going to be 37.88 milliliters, 37.88 milliliters, I think. Is that right? Yeah. Yeah. 37.88 milliliters, which is equal to 0.03788 liters of sodium hydroxide solution. That's how much we use there. And so this is going to be the moles of sodium hydroxide divided by the liters of sodium hydroxide solution, which we got from the titration, 0.03788. liters of solution. Now, the moles of sodium hydroxide we're going to get from stoichiometry. Because the reaction, if we look at the reaction here, the reaction is just going to be HCl plus NaOH yields NaCl plus H2O liquid. And again, in this case, I'm going to omit the AQs and just write the liquid here. So it's a 1-to-1 mole ratio. So we know how much HCl we have, and HCl is a standard. And so what we're going to do is we're going to go from milliliters of HCl solution to liters of HCl solution. And then from liters of HCl, we're going to get moles of HCl because we know the molarity. The molarity of the HCl was 0.1032 molar. That was a standard solution, so we know that, and so we could get the moles, and then from there we can get moles of sodium hydroxide. Once we have the moles of sodium hydroxide, we'll plug it in up here. Well, what I'm going to do is I'm just going to write this as one equation, and so this is going to be 34.46 milliliters of HCl solution times a liter per, you could do this in your head too if you wanted to, but we're going to convert from milliliters to liters of HCl solution, and then from liters of HCl solution to moles of pure HCl, because it's 0.1032 moles of pure HCl per liter of HCl solution. And then we have a 1-to-1 mole ratio. For every mole of HCl, we have 1 mole of sodium hydroxide. And so we have 1 mole of NaOH for every 1 mole of HCl that reacts. And so that's going to give us the moles of sodium hydroxide on the top divided by 0.03788 liters on the bottom of solution. And we'll be able to get the molarity from that. And so let's go ahead and punch this out on the calculator here. I'm going to get 34.46 divided by 1,000 times 0.1032 divided by 0.03788 equals. And so the molarity I calculated is 0.09388. We're allowed 4 sig figs here, and so I'll carry 1 extra, 2. So I get 0.99388 sub 2 molar sodium hydroxide. All right, that's from run 1. This is run 1. All right, now I need to do run 2 next. So for run 2, I have to set everything back up. I don't have to, get rid of the air pockets, but I have to refill the burettes, again, to make sure I have enough. And so let me go ahead and refill the burettes, and then we'll start this again. So I'm just going to get my transfer beaker and then fill the blue burette with some more sodium hydroxide. Do that here. I'm going to fill below the 0 line, and then we're going to take the initial again. Okay, I ran out of sodium hydroxide, so I'm going to get some more from my Florence flask and put it into the transfer beaker. If you have a funnel, you can pour straight from the Florence flask, but pouring from the Florence flask is very difficult because there's, in a beaker, we have a spout, a little bit of a spout. On the Florence flask, there's no spout. And so the spout really helps control drips and spills. And so I'm going to fill this below the 0 line. I'm not going to waste the time. To get it right on 0 is going to take another couple of minutes, and I don't even want to waste a couple of minutes trying to get it on 0 because it doesn't matter if we start at 0, if we start below 0, it doesn't matter. Okay, I'm going to refill the HCl below the 0 mark. Let me grab some more HCl. All right, one moment. Did I forget to start the recording? Okay, let me pause the recording for a second. All right, so I'm refilling the HCl a little bit more. All right, that's enough because this goes down to 50, so I just need 20, more than 20 in case I have to backtrack it. I'll get some more HCl in a minute. Okay, so what I'm going to do is I'm going to record the initial. So let's go ahead and record the initial. This is going to be the initial sodium hydroxide. So I'm going to make sure I'm at perpendicular. I got to make sure my camera lens is perpendicular as well. Perpendicular to the meniscus, and then let's try to record that. Take a picture of that. Okay, so that's my initial sodium hydroxide. What do you guys read? Okay, 0.47. 0.46. Let's see what I would get here. Anybody else? Chime in on that. 0.46. Yeah, 0.47 or 0.46. You know, I might be inclined for 0.46, maybe just a hair past the midway. But I can see it 0.47 as well. We'll just go with the 0.46. And so that's going to be the V initial for the base. And so V initial for the base for run 2, we'll do it 0.46 milliliters. Now, I didn't have enough acid, but I think I have to fill it, but I have enough for another titration. And so let's take a look at the acid here. And so again, I'm going to try to get this here. At the level. It's hard, the camera lens has to be perpendicular, so try one more time. Okay. What you see is this one here. Acid? Okay, let me go get some. Okay. All right, so we got to 16.29 or 16. Okay, actually, yeah, let me see what it is here. It's going to be 16.19. I can see that. 16.5. The 0.5 is actually hidden by the black background here. It's going to be 16. I could go with. I would probably go with maybe a 1.8 though. You know, because a 1.9 should be right, almost just a hair above that line there. So the line that you see below there is the 16.2, and so I would probably go with a 1.8 on that one. So we're going to start off at a 16.18 on the HCl and a 0.46 on the other one. Okay, next step is we're going to add some phenolphthalein, but I'll be right back because I need to get a clean flask, some more HCl. I have two options. One, I could just clean the one I just used. The one I just used, it's still pink. It's barely pink. Can you see it? That pink color is still persisting there. Or maybe against a white background, you might be able to see it better. So there's still, the pink color is still persisting in there. So I could clean that, but I have a clean one here. So I'm just gonna use a clean one. And so what we're gonna do here is I'm gonna add 20 milliliters of acid to this, roughly. So, link that down here. Here, let me move my notebook so in case some splashes come up. Move this other stuff here. Let's get rid of this thing here. And so I'll just hold it below the tip and then just add 20 mils. And so I was about 17, so I'll go to about 20, 17, 37. So we'll stop about 37. Oops. Wait, no. How many mils was that? 17, 16. 16 plus 20 is going to be about 37. Yeah. So stop here. I overshot a little bit. And then I'm going to add a drop of phenolphthalein or two. You don't want to use too much phenolphthalein because that could lead to potential error. I'm only going to put one drop this time. We really don't need that much. There's a drop, adhering here. The amount of acid is fixed here. So even if I add water to this, it's not going to change how many moles of acid I have in here. So I'm just going to rinse. There's a drop that's stuck there that would be hard to swirl in. And so I just rinse that in. And so adding a little bit of DI water is not going to change the moles of acid because the moles of acid is already fixed by how much I added over here. Okay, now what I'm going to do is I'm going to just go ahead and add the base in here. And when I add the base, I'm just going to add it quickly at the start because there are two reasons. If this were Chem 1A, I'd probably be a little bit more careful, as I get closer. But since I can back titrate this, it makes it a lot easier. I don't have to worry about overshooting it as much. So let's move that out of the way. Let's move this out of the way. And so I'm going to just raise the Erlenmeyer to prevent splatters. I don't want splattering happening. That's going to drop it. And then I'm just going to let it pour in here until I see the pink color, evidence of pink color. Okay, so I'm starting to see some pink color here. There's some pink in there. I'm going to swirl it, and then the pink disappeared. And so I'm still not quite there yet. Try some more. Okay, there's pink color that's coming. Let's swirl it. And again, it disappeared. So, but I'm getting closer because okay, again, pink color here. Let's swirl it. Okay. This time when I swirl it, it stayed. If this were Chem 1A, then I just screwed up this titration because I need to get it within a drop. And I was streaming it in there. And so I overshot it. But this is Chem 4. And so all I have to do is back titrate it with some acid. And so I'll add a drop of acid and see what happens. That was like 2 drops of acid. Nothing. Okay, let's add, this is going to be 2.5 drops of acid. Half a drop was stuck on the tip. Still color. 2, 3, 4. 4 drops, 4.25 drops of acid. Okay, nothing happened. Okay, another 4 drops of acid. Okay, it looks like I'm getting closer, but the color is still persisting, so. Okay, this is going to be 4.5 drops of acid. Maybe I was far off. I probably overshot it. If you overshoot a lot, then you're going to be here a long time doing this. I'll go with another 4 drops. No. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's go with about 10 drops of acid this time. Okay, with 10 drops of acid, the color disappeared. And so I know I'm within 10 drops here for the base. And so I'm going to go dropwise. So I'm just going to add a drop. Oops, shoot. I added a stream of base. Unfortunately, I added too much. So let's add a drop here. That was 2 drops. Okay, actually, a little bit of color. So I'm going to add 1 more drop. Okay, now that's pretty colorless there. Go back over here. Okay, I'm going to add just a 1/2 drop. So I suspend a 1/2 drop on there. Let's see what happened. And so I'm going to rinse that 1/2 drop in with my wash bottle. Check the color. Pretty colorless. Okay, let's do another 1/2 drop here. Oh, this is leaking again. Let me tighten up. I'm going to tighten this little nut here, make it tighter. And we got color there. That was more than a drop. That was like 3 drops or something. And there's a very faint pink color there. And so what I'm going to do is I'm going to just add a little bit more base to that. Let's go with a 1/2 drop of base. Oops, that was a full drop. Well, a full drop is now colorless. Pretty much, yeah. There's a little bit suspended on there, so that little bit that's suspended, I'm going to try to rinse that in. Otherwise, it's going to be counted. Okay, so that's colorless. So let me rotate this back over here and raise this. I need to raise this up a little bit. Okay, so I'm going to just get a 1/2 drop on there. Okay, that's probably 1/3 of a drop. And then I'm going to wash that in. No color. So repeat that. Okay, this is about a 1/2 drop suspended. This one I'll just tap in here. Okay, and then rinse off the walls. Okay, now I got color. Okay, but the color is not persisting. I mean, it's fading. And so let's do that again. Another 1/2 drop. Okay, so I got a 1/2 drop there. I'm going to rinse that in. Oops. I might have rinsed that on the outside. I need to drop the tip down more. Okay, there's barely any color there. I don't think it's going to last. I need to lower this burette a little bit so I don't spray it on the outside. And there's some water on there. And so, again, I'm going to do just a 1/2 drop here. It's probably hard to see it. Okay. There's a half a drop suspended on there. I'm going to tap it in. There, it's on the wall. Then rinse it off the wall. Okay, now I got color. Okay, let's see if this color persists for 30 seconds. Let me hit the timer. Okay, that's been 30 seconds. There's barely perceptible color there. And it faded, it lasted for about a little bit more than 30 seconds, and now it's faded. And so since it was right on the border there, I'm gonna add another quarter drop maybe. Or that's about a half a drop. I'll add about a half a drop. This one I'm gonna spray in here. And then swirl. Okay, so this one has a more perceptible color. It's still very hard to see the color, but I'm sure it's more difficult through the camera, but I can see it here, barely. Let's see if this one persists for 30 seconds. All right, that's been more than 30 seconds. It's still there, but it's barely detectable. I mean, I might be tempted to add another half drop, but it's all right. It's barely detectable, but it's still there, so we'll just go with that. So, it might be like another half drop shy. Okay, so that one's done. Let's go ahead and take some readings here for our volumes. And so we'll get the base volume here. So I'm going to take a picture of this one. Well, move this over here. That's about right. Yeah, maybe. Okay, so what do you guys see for this reading here? $25.22. Yeah, I could go with that. 25 point, not quite 25.3. The 0.3 is the next line down. And so, this would be the 25.3 line below there. There could be, I could have been a little low when I shot this. So, but I think 25.22. Okay, it's between the 0.2 and the 0.3 line, so it's not all the way down to the 0.3, which would be the next line down. That was the base, the 25.22. We'll just go with that, milliliters. Let's get the acid next. So with the acid, okay, I'm going to take it off here and then just read it here, this. Okay. It's between 40 and 41 milliliters. And so it's 40 point, it looks like it's between 0.6 and 0.7. So it's between 40.6 and 40.7. What would you call that? $40.68? Maybe. It's a little bit, I'd probably say it's 6.7 because it's just a little bit past halfway. And 6.8, I'd expect a little bit closer to the 40.7 line. And so maybe let's go with the 40.67 on that one. And so 40.67 milliliters. All right, now let's compare that to our first run. We're going to redo the calculation. We have to do the calculation because we want to see how consistent our runs are. You know, this should give us the same concentration. So let's see how close the concentration comes out here. And so what we want to do is we want to calculate the molarities. So what we're going to do is we're going to calculate the volumes again. I screwed up. I just realized I did something for the first calculation. I made a mistake here. I forgot to calculate the volume of the HCl. The volume of the HCl is not 34.46. The volume of the HCl is 34.46 minus 0.32. I mean 36, where did I get 34.46? I don't know. Well, okay, let me redo that calculation from 1. And so the volume here is 36.14 milliliters. That's the volume of the HCl. I don't know how I did that, but this is why you want to do these calculations in your notebook. Because you can make mistakes here. You don't want to make a mistake on your report sheet like this. Can't cross it out. And so when we make a mistake, we just cross it out with a single line or 2 lines. We try to keep it legible still. And so let me redo the calculation from the first run. It's 36.14 divided by 1,000 times 0.1032 divided by 0.3788, 0.03788, 0.03788 equals. It should have been 0.09845 sub 9 molar NaOH. And so the same thing here, I have to calculate the volume of the HCl that I used and the volume of the NaOH that I used. And so the volume of the HCl I used is going to be 40.67 minus 1618, where we started, minus 1618, 24.49. And then the volume of NaOH that I used is going to be 25.22 minus 0.46, which is going to be 2476 milliliters. Okay, then I'm going to plug these volumes into the equation. So this is the volume of HCl here. So the molarity of the sodium hydroxide for run 2 is going to equal, I'm going to convert this to liters here. This is 0.02449 liters. I just moved 3 decimal places over. So I'm just going to say 0.02449 liters of solution. This is HCl solution times the molarity of the HCl. It's a standard. It's 0.1032 moles of pure HCl per liter of solution, HCl solution, and then convert that into moles of sodium hydroxide. It's a 1-to-1 mole ratio. So 1 mole of sodium hydroxide for every 1 mole of HCl. Divided by the volume of the sodium hydroxide in liters. So the volume of sodium hydroxide solution is 0.02476 liters. So we'll divide by 0.02476 liters of sodium hydroxide solution. And so let's see what that comes out to. So I'm going to go to 0.02449 times 0.1032 divided by 0.02476. Okay, this one I'm going to get 0.10207 molar sodium hydroxide. And so what I want to do is I want to calculate something called the percent difference. These two numbers should be the same. You know, run 1 and 2 should give the same molarity. And so what we're going to do is we're going to calculate something called the percent difference. The percent difference is going to be the it's going to be the biggest minus the smallest divided by the smallest times 100%. And so the biggest molarity is the 1020 sub 7. 1020 sub 7. The smallest is this 0.098459 divided by the smallest 0.098459 times 100%. And so I'm going to just leave that in my calculator and then just do minus 0.09845 equals divided by 0.098459. I forgot to add that 9 earlier, times 100. And so when I see this, I see there's a 3%, 3.68 actually, 3.68% difference. 3.68% difference. This is too big. Way too big, because what I want for my percent difference between the runs is within 0.5%. And so the percent difference max should be no bigger than 0.5%. My percent difference is 3.7%. It's way too big. So there's something I really screwed up on this titration. I don't know which one I screwed up, run 1 or run 2 or both. But I'm going to do a third trial to see you know, maybe it's closer to run 1, maybe it's closer to run 2, or maybe I screwed up the calculation. I don't know, but something's way off. And so I should just take a quick look at the numbers and then see. All right, so what we're gonna do is we're gonna do run 3 now. So why don't you take a look at the numbers and see, did I screw up the calculations? If I didn't screw up the calculations, then I screwed up the experiment because I'm not getting good precision. I want good precision. And so I'm gonna grab some more acid. I'll be back and do that. The break time. Break time is in 3 minutes. Okay, we'll just go on break right now. Let's go on break and then we'll be back in 15. I gotta get more acid. And I don't know if this acid, I might dump the acid I have in there right now because it has been contaminated. I'll be back. Okay, I grabbed some funnels. These are burette funnels here. And so we could use burette funnels to fill this. So I already cleaned these and dried them. So I'm gonna add some base here to this. When you fill with the funnel, you have to lift the funnel up a little bit to create a little air gap here. Otherwise, it doesn't flow very fast. And so we have to lift that up. I'm going to fill this below the 0 line with base. Blue is for base. And then the red is for the acid. So I'm going to get the acid here, HCl. Lift the funnel up to create a little air gap and fill this with a funnel. Okay. Now, we'll get this is going to be run 3. And so we'll get the readings for the initial run 3 here. Make sure the camera's lined up. Okay, this is for the base. It's a little bit blurry, but can you see it? It's right below the 0 mark. So what would you call that? Right below the 0 mark. All right. Well, 0.1's the next line down. Yeah, 0.01 or 0.02. Let me try to get this in focus. The focus didn't come out. Delete this photo. I have parallax there. If you look at the top ring, can you see, I can see the back of the top ring. That means I'm looking at it too high. And so that's parallax. Because I can see the top black line, I can see the back of it. I shouldn't be able to see the back of it. And so my camera's too high. So I'm going to delete this one. And I'm going to take another photo here. Now, when I look at the top line, I can't see the back of the top line here. See that? And so I know I'm looking at a perpendicular. And so what do you call that one there? And so I'd say that's a 0.01 or 0.02. I might go with a 0.02 there because 0.01 would be almost right on that line, you know, just a hair. Here. And so 0.01 is okay too, but let me go with a 0.02 on that one. Okay, so this is going to be run 3. The volume initial for the base, 0.02 milliliters. Sodium hydroxide. Okay, let's record the acid. Okay, it came out blurry. Let me try that again. Hopefully that one didn't come out too blurry. All right, what would you call this one? This one looks like it's right on the 0 line. Do you see that? I didn't intentionally put it on the 0, but it looks like it just got right on the 0. So if it's right on the 0, yeah, then it would be 0.00. And so that would be the HCl, 0.00 milliliters. Okay, now let's set up the titration once again. So I'm going to bring the camera back over here. And, let's take a look. This here. Let me get a clean Erlenmeyer. Here. Okay, now I need to add my acid in here, about 20 milliliters. So I'm going to drain this to about 20 mils here. Move this stuff out of the way. Oops, I got a drop on the outside. Shoot. There's a drop hanging on the outside. Change the line. So, in this case, oops, got more than a drop on the outside there. This one I screwed up. And so this one I spilled on the outside. So I'm going to trash that run. So I'm going to trash that run. I need a new flask, a clean flask. So I'm just going to dump this one. I'm going to dump this one. I'm going to rinse it with some water. I'm not going to use soap on this. I'm just going to rinse with tap. And then I'm going to give it a final rinse with DI water. Because it should just be a little bit of salty water, you know, sodium chloride. So I'll give it a 2 rinses with DI water. That's it. So that one I screwed up because what happened was as I was pouring the acid in, some spilled on the outside of the flask. Now the flask doesn't have to be dry. This flask is wet. And just because it's wet with DI water is not going to change the amount of acid I have in here. Okay, but I have to re-record the initial, you know, acid because now it's changed. And so I'm going to re-measure the initial acid here. And then this is going to be my new initial because it had changed. And so when I look at this one, it's almost on the 14. And so it's 13.9 something. What would you say? 13.9 what? 13.97? Okay. 13.90 would be right on the right on the 90 mark. The 13.9 line is here. And it's not lining up with the 13.90. It's between 90 and 14, and so, yeah, 97. Okay, we're gonna go with 13.97. And so what I'm gonna do is I'm gonna cross out my initial HCl. Oh, that's too bad I had it right on 0, and go with 13.97 milliliters here. And so I need to add about 20, so I'm gonna go down to 23. Now again, this doesn't have to be dry, it can be wet with DI water. DI water is not gonna be a problem with the acid. Okay, this time I'm gonna be careful. I'm gonna put the tip below the mouth of the Erlenmeyer so none spills out. And then I'm gonna drain this to about 20, let's see, 33, 34. Okay, so I got more than 20 milliliters. That's okay, I'll measure it later. So I have my acid in here, about 20 mils. And then I'm gonna get a drop of phenolphthalein. I'll put in 2 drops. I should be consistent. Each time you wanna put in the same amount. So run 1, I put in 2 drops. Run 2, I put in 1 drop. I should be consistent because it leads to a small error in the indicator itself. Okay, so now I'm ready to try the titration one more time. And so it's taking about the same amount, you know, of, let's take a look at the numbers here and see with run 1. With run 1, I had 36 milliliters of acid and 38 milliliters of base. Run 2, I had 16 milliliters of, 24 milliliters of acid and about 24. So it's taking about the same amount. And so what I'm gonna do is I'm gonna add about the same amount, 20. So I'll add 20 mils rapidly. And then after that, I'm gonna slow down. I actually added about 21 mils. And so I'll add this rapidly. I'm gonna keep my eye up here and watch it. As it gets down to about 20, I'll slow down and stop. Okay, so that's 20 milliliters. And as you can see, it's pink down here already. And so let's swirl this and see if that pink color persists. No, the pink color disappeared here. And so that wasn't enough. And so what we're gonna do is now I'm gonna go slow here, since I know I'm close. And so, oops. Okay, that disappeared. Okay, let's increase the drip rate here. I'm gonna go drop, drop, drop. So I'll just drop it in at a slow rate here. Okay, now it's turning pink. So I'll stop there. That was about 5 or 6 drops. There's a drop hanging, so I'll wash that in. Now it's quite pink. And that was about 6 drops. So I'm going to back titrate this with the acid now. And so let's add just 1 drop of acid and see what happens here. Okay, that was 1 drop of acid. Okay, it's still pink. Let me try to add 1 more drop of acid here. Okay. No, another drop of acid. It's just about gone. 1 more drop should do it. That's another, actually there's a half drop suspended, so I'll just put that in there. Okay. And so I'm gonna go back here. I'm gonna make sure I rinse off the walls of this and then go back here and I'm gonna try to add a half a drop of base. So let's try to add a half a drop. There. Let me tap that in. Let's swirl this. Okay, I have a very, very faint color, pink. but I think it's not going to persist. So let's add one more half a drop. Okay, that's a half a drop there. I'm going to tap it in this time. Okay, now I have a more pink color to it here. So that was within a half a drop or so. Let's see if this lasts 30 seconds. So I'm going to do the timer here. Stopwatch. No, it's not going to last. The color's gone. So let me stop that. Reset that. So let me add another half a drop. So suspended a half drop, tap it in on the inside wall, and then rinse it in here. And so now I have a faint pink color. Let's see if that persists for 30 seconds. So here. Make sure there's no residual drops appearing on the inside wall. Make sure everything's washed in. This is 20 seconds. All right, that's 30 seconds. Okay, so the color persisted for 30 seconds. There's still a very faint pink color there. And so now we're ready to take our final measurements here. Let me get the final measurement of base here first. And so I'll take a shot of that. So what I'm doing, I'm moving the camera up and down to see, the lines behind the lines. I want to make sure that it's hard to get that lens lined up right, and that could be leading to the error as well. But what do you see there? It's 21, so it's between 20 and 21. So it's 20 point, it looks like it's 20.567, 20.7. It's right past 20.7. What do you guys see? There's 20. So it wouldn't be 0.29. 20.71? Okay. We could go with that. There. 27.1 is, no, we're not even close to 27. 27.1 is way down there. You probably meant 20.71. Okay, let's go with 20.71. All right, that was the base, 20.71 milliliters. Okay, let's do the acid next. So take a look at the acid here. With the camera, it's hard to, because the lens is all the way at the top. And so it's hard to line it up. And so I could be getting bad readings because I'm not lining up the camera lens properly. But anyway, we'll just go with it. This is the acid. So it looks like it's 34.7. almost right on the 7, just maybe a hair below the 7 line, 34.7. You see, it's just slightly below the 34.7. If it was right on the line, I'd call it 34.70, but this one I'll call it 7.1, yeah. Let's go with 34.71. 34.71 milliliters. Okay, now let's see how this titration went. Hopefully went okay, but we'll find out. And so let's figure out the volume of base. The volume of base is going to be 20.69 milliliters. And the volume of acid is 3471 minus 1397. You can calculate that if you want on the calculator. 34.71 minus 13.9 or 7. 20.74 milliliters. And so this is V final. Okay, then let's calculate the molarity of the sodium hydroxide. The molarity of the sodium hydroxide is going to be equal to the volume of HCl in liters. So this is 0.02074 liters. 0.02074 liters of HCl solution times the molarity of the HCl, 0.1032 moles of pure HCl per liter of HCl solution. And then convert that to moles of NaOH. 1 mole of NaOH for every 1 mole of HCl. Okay, that gives us moles of NaOH on the top divided by liters of NaOH solution. The liters of NaOH solution is 0.02069 liters. 0.02069 liters. And so let's calculate the molarity here. And so it's going to be 0.02074 times 0.1032 divided by 0.02069. And this gives me a molarity of 0.10344 molar. All right. And so that run seems to agree okay with run 2. You know, let's see what run 2 was again. Run 2 is 1034.4. Run 3, oh no, that was run 3, sorry. Run 3 was 1034.4. Run 2 was 1020. 1020 sub 7. 1020 sub 7. And so let's calculate the percent difference between run 3 and 2. And so it's the bigger point, 1034.4 minus the smaller point, 1020. 1020 sub 7 divided by 0.1020 sub 7 times 100%. And so we'll have that. I'll just leave that in my calculator. Minus 0.1020 sub 7 equals divided by 0.1027 times 100%. Okay, this came out to 1.35% difference. This is still too big. Too big. And so that's a problem. It has to be less than 0.5%. So something is wrong with my titration technique, but that's okay because what we have to do is we have to keep practicing until we get it to the precision that we want. And so it doesn't matter how many runs it takes, you know. We need 3 trials that agree within 0.5%. And so I'm going to have to do another trial right now. So let's set that up. Here. Okay, the acid, I don't have enough here, but I have enough base. You know, I have more than 20 milliliters base, looks like. So I'm going to, on the next run, I'm just going to add acid. I'm not going to add the base here. And so I'll add some more acid to this. There. And then what we're going to do is we're going to use the final volume of base as our initial volume for run 4. And then since I refilled this acid for run 4, we're going to have to remeasure the initial here. Okay. So what do you get? This is the initial acid now, run 4. .38. Okay. Anybody else? .38. It's 0.39. I would actually go with a 0.37 on this one. Is a 3.9 would be a lot closer to the line, and then a 3.8 would be close to that, and a 3.7. Then you got a 3.6 and a 3.5. 3.5 would be right in the center there. And so, you know, you have to look at, there's one line there that's hard to see. And that's probably why you might have gotten the 3.9 there, but you see there's one line that's really hard to see because it's in the black zone there. And so if we count it, there's actually 2 lines. I would go with, let's just, for run 4, this will be run 3. For run 4, the acid, I'm just going to go with it's probably hard to see from your perspective because that line is kind of hidden, but it's more of a 0.37 milliliters, the acid. Now for the base, we're going to use, I didn't add any for the base, so we're just going to use the last volume as a starting volume for here, and that's going to be 20.71. That'll save us some time. And so the final volume from the last run for the base was 20.71, and I didn't add any, so we're just going to, because I have enough. This is a 50 milliliter burette, and so I'm pretty sure I have enough. So I can clean the flask, or I can just get a new flask. I'm going to get a new flask here. Okay, and then I'm going to add about 20 milliliters of acid to this. So let's stop around 20. Yeah, that's around 20. Then add a drop of phenolphthalein, 2 drops. Actually, 1 or 2 drops. Sure. In this case, I added 2 drops. And then let me rotate this so I can get this. So that was about 20. This is going to take about 20. And so last run I stopped about 20.7. So I'm going to go to about 30.7. No, 40.7. And so around 40.7 I'll stop. Actually before 40.7 I'll stop. With in Chem 1A you can't go backwards. That is, in Chem 1A, we only use one burette, the base burette. And so if we're only using one burette, we never want to overshoot this. And so in this case, I'm going to do more of a Chem 1A style because I don't want to overshoot this. Because if I overshoot this, then I have to start all over again. And that's what it's going to be like in Chem 1A. And so I have to be very careful. And so now I added about 20 milliliters here. So I'm going to just go drop by drop. It's going to take a lot longer this way if I go drop by drop, but I won't overshoot. So I'll add a drop here. Oops, that was more than a drop. It's still not turning very pink. So drop, hasn't turned pink. Another drop. Another drop. Okay, now it's starting to turn a little bit pink, so I gotta be careful. I might wanna go half a drop, but I'll go full drop here. Full drop. Nothing. Another full drop. Oh, wait a minute. I started at 20. No wonder. If I start at 20, I need to go to 40. And so if I stopped at 30 and go drop by drop, that's 10 milliliters. Well, there's about 20 drops per milliliter. So that's 200 drops. I'd be doing 200 drops to go from 30 to 40. That would have taken way too long. And so I stopped way too early. I miscalculated that. I need to go to about 40. So I'm going to stop before 40. Actually, now it's starting to turn pink here, but the pink color disappears rapidly. So I'm going to go to 39. Maybe I'll go to 39 and a half. I'll go to 39 and a half. Now I can do, I mean, you know, if I go from 39 and a half to about 40 and a half, that's 20 drops, roughly. So maybe I could go drop by drop, 20 to 30 drops. That'll be okay. It won't take so long. And so there's a drop, nothing. Another drop, nothing. Persist. Another drop. Okay, nothing. Nothing. Persisting. Nothing persisting. Actually, what was I? I started at 20.7, so it's more like 40.7. And so I'm going to add another, let's say, half a milliliter quickly. Like 10 drops quickly. Okay. And so now slow down a bit. Okay, I'm at 40.6 roughly. Okay. I went too far, I think. Went too far. And so now it's pink. It's actually a pretty dark pink in this case. Let's see how far I went. And so what I'm going to do is I'm going to just try to back titrate. This is the advantage of Chem 4. In Chem 1A, I might have had to toss this because that was within maybe 3 drops. Let me see here. I'm going to add just 1 drop. Oh, that was 2 drops. Okay, actually I was within 2 drops. And so I'm going to add a half a drop now. I want to get this within a half a drop. Okay, so I have a very light pink color. Let me see if that light pink color persists. This is within a half a drop for 30 seconds. All right, it looks as if the color disappeared. And so let me go with another half a drop. Here. So in Chem 1A, the titrations are going to take a lot longer because you have to slow down much sooner. Okay, this is within a half a drop. There's some color there. And let's see if that color persists for 30 seconds or so. And so that's within a half a drop. All right, looks like the color is still there, so we're good. Color's still there. This is a little darker than the other ones, but it's okay. All right, so let's go ahead and take our measurements. We get some decent results here this time. Okay, let's go with the acid here first. Okay, it's at, it's kind of hard to see there. It's between 20 and 21. So it's between 20.3 and 20.4. 20.3 and 20.4. So it's 20.3 what? $20.32. Anybody else? 23.4 hasn't hit that line. The 23.4 line is below there. It's the next line down. And so this one, it looks like it's like a 23.3 or a 23.2. And so, yeah, 23.33 sounds right. And so let's go with that. The acid is 23.33. Let's figure out what the base is here next. So let's lower this down so I can take a reading. Okay, I'm figuring out how to figure out the camera. I'm looking at the line behind there and just trying to adjust it so it's in the center. And so that could be the reason why my precision's so bad, is because sometimes I'm holding the camera too low, sometimes I'm holding it too high. So this is 40.5.6. So it looks like it's between 40.6 and 40.7. And so what do you see there? Maybe hard to see because the line is, yeah, it looks like a 6.1. That looks reasonable. Maybe a 6.2 is the line. We'll go with 6.1. So that's going to be a 40.61. All right, so let's take a look at our at this run 4, and see where we come up with. And so we're going to calculate the volume of sodium hydroxide. 40.61 minus 20.71 would be 19.90. sodium hydroxide. And is that right? 23. Wow, there's something weird for sure with my numbers here. 23.33 minus 0.37, 2296. Unless I'm misreading that, 20.71. The thing that's, this thing that I see here is going to be way off. Look at, this is about the same volume. This is about 2 milliliters or 3 milliliters more. How could that have happened? I must have misread something. Let me just double check it. 20. Oh, I see. I did. This is not 2333. It's 20.33. 20.33. $19.96. Okay, now it looks more consistent. It's about the same volume like the other runs. Okay, so let's go ahead and calculate the HCl molarity. So it's the same equation as this here. So I'm just going to go ahead and plug in the liters here. This is going to be, no, actually I have it here. So it's 1996, and then I'm going to divide it by 1,000. It's going to give me liters. 0.1996 liters times 0.1032 divided by the volume of sodium hydroxide. It's going to be 0.01990. 0.01990. 0.1035. So the molarity of the sodium hydroxide is basically the same setup. It's going to be 0.1035 sub 1 molar. Okay, now this one in run 4 we got 1035, in run 1 we got 1034. And so let's calculate the percent difference between run 4 and run 3. And so it's going to be the biggest, which would be 1035.1. I'll just leave it in my calculator, minus the smallest, 1034.4 equals, divided by the smallest, 0.1034.4 times 100%. Okay. Now this is good because now the percent difference is just 0.068%. And so this is well below our 5%, 0.5%. This is well below our 0.5% max. And so run 4 and 3 are good. So all I need is one more run that agrees with run 4 and 3 within 0.5%. And so let's try to get that. One more run that agrees with run 4 and 3. Hopefully I can get it, but we'll see. Okay, now I'm going to have to refill both. Of these. So the blue is the base, so let's add some sodium hydroxide to this one. Here, I'm gonna raise the funnel, fill it to below the 0 line. And then the HCl. HCl, you know what? I have enough. I don't need to refill it because I can go down to 50. So I'm just going to use the last volume here as my first volume. on the HCl for run 5. And so run 5, let's get the new sodium hydroxide initial. I think that came out okay. Let me see. Yeah, probably. So what would you call that? Okay, it's going to be 0.0, because the first line is 0.1. 0.6 is down here. That's 0.6. So it goes 0.1, 0.2, 0.3, 0.4, 0.5. 0.5 is in the middle. So 0.06 or 0.07. Okay, go with that. Anybody else? 0.05. Okay. Let's take a look. Yeah, this it's blurry, so that's one of the things. It's hard to read. Let me just do one more photo to see if I can get a shot more in focus. This is a problem with the camera. You know, the lens is way up here, so I have a hard time figuring out when the lens is perpendicular to the meniscus. So sometimes I hold it a little high, sometimes I hold it a little low. That's causing bad precision for me in the photographs. Because now look at it. When you look at it, I just have it slightly higher or slightly lower. In this case, it's slightly lower and it's reading, or slightly higher, and then it's reading 0.1, like a 0.10 or something, or 0.09, you know? And so that's the problem. If the lens were right in the center, then I could center it right on the meniscus, but the lens is right here, so it's kind of tricky to do that. And so it's giving bad precision. So I'm trying to get the lens height and then get it in focus. And so there, I think I kind of got it, you know, more. You can see it's farther. It's more like a 0.0. In this case, it's actually I didn't really get it right, because if you look at on the right edge there, you can see the back of the zero mark. And so this one isn't a good photo either, because I'm getting parallax. That is, I'm not perpendicular. I don't want to be able to see the back of the zero mark. And so in this case, I'm going to raise it up so I can see the back of the zero mark, and then I'm going to lower it down until I can't see it, and then lower it down until I see it again, and then raise it up. They're pretty hard to see, actually. I think that's it. Okay, so now when you look at it, do you see it's more like a 0.04, you know? But if I look at the zero mark, I can kind of see the back from the bottom, so maybe it's not, didn't do such a great job. So if I'm reading it from a little low, then it's going to read a little higher. So it's like a 0.04, 0.05, 0.06, you know, depending on how I line up the camera. And so one more try here. It's much easier to do with your eye, you know. I think. Let's try to zoom in. That's probably, I should have probably tried to zoom in earlier. Okay, now it's a lot easier. I think I wasn't zooming in is my problem. Okay, now when I look at, well, I see a double image on the 0. And so I'm not perfect there either. Because if you look on the left edge, you can see a double image on the 0 line. On the right edge, it looks okay. On the left edge, I see a little bit of double image, which means I'm seeing the back. But in this case, it's more like a 0.08, you know, or maybe even 0.08, getting close to a 0.09. And so that's giving me inconsistencies in this, and that's going to lead to making it hard to get good precision, that is good reproducible results. And so let me just blow this up as much as I can. So I'm zooming in as tight as I can. I'm going to try to get it as focused as possible. And try to avoid getting parallax. But my camera won't focus this close. Maybe with the newer iPhones it could. Okay, it was hard to hold it steady. Well, there's still a little bit of parallax there. I can still see double image on the 0 line, which I don't like, but that's all right. We're just going to go with it. Otherwise, I'm wasting too much time. And so what do you call this? .05? You know, it looks like it's just slightly past the 0.05, you know, slightly past the midway point. I would go with a 0.06 on this one, I'm thinking. Just slightly past. And so let's go with a 0.06 here. All right, wow, that took a long time. So that was sodium hydroxide, 0.06 milliliters. And the HCl, we're going to use the same as the final volume on the last run. The final volume on the last run was a 20.33. So yeah, that looks about right, 20.33. Okay, now I ran out of clean Erlenmeyer, so what I'm gonna do is I'm gonna just dump one of these. I'm gonna rinse it in water. I'm not going to wash it with soap because it just should be just salt, you know, salt water and some phenolphthalein. So I'm just going to rinse with tap water. That should be enough to rinse out the salt, and DI water, which should be enough to rinse out the salt. Okay, this I'm just going to dry on the outside. I'm not going to dry it on the inside because, you know, having water inside here is not going to change, you know, how much acid I put in here. Okay, so I'm starting about 20. I'm going to go 20.3. I'm going to go down to 40.3. So I'm going to look 40 right there. I'm going to stop it around 40.3. Okay, that's a little bit less than 40.3 there. And let me just tap to see, make sure there's no drops here. Okay, now let's go back over here. And we're going to do this. Here. This is a half a drop hanging there, unfortunately. So that's going to lead to a little bit of error, but that's all right. Nothing much we can do about it. Now, I added about 40 here, so I'm going to add about 40 here. And so I'm starting up near the top, so I'm going to go down to about 20 fast. I mean, I added 20 there, so I'm going to add about 20 here, not 40. Okay, so that was 20 milliliters fast. Okay, then what I'm going to do is I'm going to do Chem 1A style. Chem 1A style is we can't overshoot. We only have one burette. We only have the base burette, and we're not allowed to overshoot this. And so, so that means we got to be careful here. Oops, and I put in like 3 drops in there, but that's okay. I'm going to put another drop in. Okay, no pink with that drop. I'll put another drop in. Okay, no pink color. Another drop. Nothing. Nothing. Nope. 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 Well, did I put in phenolphthalein? That's a rookie mistake. Rookie mistake is to forget the phenolphthalein. I was thinking I forgot the phenolphthalein because I wasn't seeing any pink. But now I got plenty of pink. I overshot it. Okay, this would be a trash run in Chem 1A. I'd have to dump this and start over again, which is really too bad, because that would have probably been a good run. But since this is Chem 4, I can go back and add a drop of acid. And so now I'm back on the acid burette. I'm going to add another drop of acid here. See if I can get rid of that pink color. So I overshot it by more than a drop. There's 2 drops of acid. Three drops of acid. 4 drops of acid. Looks like I overshot it by 4 drops at least, you know. These aren't the same concentration, but anyway. Let's wash in the splatters. Okay, let's go back to the base. Now I'm gonna try to get this within a half a drop. And so I'm only gonna add a half a drop this time to this. And so let me suspend it. Oops, gosh. I put in a full drop. Put in a full drop and it's colored, and then there's a half a drop suspended there. Let's see what that half drop does. And so I got color there, a little bit of color. And so I might have, I accidentally put 1.5 drops. And so what I'm going to do is I'm going to just put in a half a drop. I'll put in a full drop. Let me put a full drop of acid in there. Go back to colorless, and then let's try this again with a half a drop of base. Okay, I have a half a drop suspended. I'm going to wash that in. Here. Okay, no color there. Let's add another half a drop. Okay, half a drop suspended there. Let's wash that in. And I got color here. It's not a very dark color. Let's see if it's going to last. No, it faded. And so let's add another half a drop. Oh, shoot. That was more than a half a drop. It was like 3 drops. Three little drops. It's very close. I mean, this is barely pink. Let me try a half a drop of acid. Actually, let's go with a full drop. I'll go with a full drop of acid. This stopcock is easier to control. This stopcock is a little loose. That's probably why it's leaking. Even with the nut tightened there. So I think the O-ring is. And so I'm going to go a half a drop now. Okay, half a drop. Okay, I had some color, but it faded. So let me go with another half a drop. Okay, some color there, but it faded. Go with a half a drop. Let me tighten this up even more. Rinse this. Okay, now I got some color. Let's see if this color persists for 30 seconds. Here. Well, it's been about 20 seconds and it's faded. It took about 20 seconds to fade. So another half a drop here. So let's see how long this color lasts. So I got lucky. I got lucky because it's a Chem 4, so I could back titrate. Otherwise, I had 2 or 3 failed. If I'm trying to hit a half a drop, I failed. But if I'm trying to get it within a couple of drops, then it was okay. All right, that's 30 seconds. The color's still there. It's very, very faint, but the color's still there. You see it. Okay, let's go ahead and take our readings and see what we got here. Okay, the base. Camera, I gotta zoom in this time all the way. Take one more shot. Okay, this is, because I zoomed in here, this is 20.8 something. It's, okay, if we look at this line here, this line is the 20.8, this is 20.9. So it's 20.8 what? Let's see, 20.87. I'm looking at it right from the bottom here. Maybe, yeah, 7, but maybe an 8. No. 9 or 7. 7 or 8 is fine. This one, I think. Let's take a look at the previous picture. I took 2 pictures. Now take a look at this picture. This is 20.8, this is 20.9. But if you look at the this line here, you just see the double image. The double image on this line is, I'm slightly off. It's hard to line this up because I want to get a single image, but this line doesn't wrap all the way around. So I can see the back of the line here. So we have that double image. And so it's hard, you know, to line it here. There's no double image, but then I'm a little bit low because there's no double image here, but I'm reading up here, but you can see the difference in the measurements. This is more of a 28.5, whereas this is more of a 28.8, you know. And so it makes it 8.5. Well, we'll just go with the second one, you know. And so that was the base, 20.88 milliliters. We'll just go with that. All right, now let's take a look at the acid next. Try to get the acid here. Reading. Oops, there went my funnels. Check those. See, it's almost time. Shoot. We'll just do this one run. We'll get the calculation done and then see where we left off. Okay, this one is at a 40.79, maybe? You see it? 40.79. Maybe even a 40.80, you know, but we'll go with a 40.79. 40.79, and then let me just do this calculation really quick to see where we're at in terms of molarity. Or actually, well, we're out of time, so I'll let you do this calculation. Why don't you do this calculation and see where we're at in terms of molarity. We'll have to continue this on Monday. On Monday is going to be another lab day. And so on Monday I had the experiment 12 schedule. I'm going to have to maybe shorten experiment 12 so we can complete experiment 10. It takes a long time doing it from the camera. Okay, so we'll wrap things up now. Go ahead and calculate the molarity for this one and see how well it agrees with the other 4. Okay, hopefully we get 3. All right, any questions before we wrap it up? I'll try to get the exams posted, you know, soon.
Professor, when are you gonna post this video?
Oh, the videos? Yeah, I forgot to post the videos. I'm gonna be posting videos. I'll start posting them today.
Yeah, okay, thank you.
Okay, yeah, sorry about that. Okay. All right, well, have a nice weekend, you guys. And then next week, remember, next week's the final exam. So you guys want to start preparing for the final exam. And we have another test. So it's gonna be a busy week. All right, I'll see you guys Monday then. Have a nice weekend. Bye. Thanks. Let's see.